table. Well, these are all values that we should already know from the last test. So starting with 0. So I think of it one of two ways. I either am imagining my coordinate plane, in which I know 0 is this point over here. What coordinate point is that? 1, 0. And r is always 1. Okay, so remember sine is y over r. This is a coordinate point, so this is x and y. If I put y over r here, what am I going to get? Right, because 0 over 1 simplifies to 0. Okay? Then they asked for pi 6. So now I either imagine a triangle with a theta of pi 6, or if you were somebody who didn't memorize and you use the hand thing, you can do that too. So pi 6, remember, would be my ring finger. And sine is the number of fingers to the right. How many fingers do I have to the right here? 1. So that's 1, and we always put sine over 2. Okay. All right, then they asked for pi fourths. Pi fourths would be our middle finger. How many fingers are to the right? 2. So that would be square root of 2 over 2. Good. All right, then they ask for pi thirds. Pi thirds is our index finger. How many fingers are to the right? 3. So that would be square root of 3 over 2. Right, always over 2. Okay? And then we got pi halves, which we either, remember, is this point up here, the coordinate point 0, 1, or on my hand, that would be my thumb. And how many fingers are to the right of my thumb? 4. So square root of 4. What is the square root of 4? 2. So that'd be 2 over 2, or just 1. Or I look at my coordinate point here, 1 over 1, which is also 1. Okay. And then, if you guys remember, we said from quadrant 1, as I go around the unit circle, it's the same ratios over and over again. They just change signs depending on which quadrant I'm in, right? Okay, so this chart right here has 2 pi thirds, 3 pi fourths, and 5 pi sixths in it. So what quadrant would that be? 2. Okay, in quadrant 2, is sine positive or negative? Positive, right? All students take classes. Okay, good. So these are all going to be positive. For this one, 2 pi thirds, that 3 in the bottom tells us that our reference angle, or our distance from the x-axis, is pi thirds, or 60 degrees. So that's this finger. So what's that ratio? Right. So we got square root of 3 over 2. All right. 3 pi fourths, the 4 in the bottom tells us we're 45 degrees, or pi fourths from the x-axis. So that's our middle finger. So what's that ratio? Good. All right, and then 5 pi 6, the 6 tells us we're 1/6 the way, or 30 degrees. So what would that ratio be? 1. Good, 1 over 2. All right, and then we've got pi. So pi, I either need to say, okay, I know that that's over on this side, but it's equivalent to 0. Or I can say, okay, I know what this point is. This point right here is -1, 0. Either way, the y value is 0, right? And 0 over 1 is 0. Okay, the next chart here, we've got 7 pi 6, 5 pi fourths, and 4 pi thirds. Which quadrant are all of those things in? The third. Okay, is sine positive or negative in the third quadrant? Negative. So I need to go and put a negative in all these boxes, because whatever we come up with, it's got to be negative. Okay, so 7 pi 6. Pi 6, remember that's equivalent to 30 degrees, or pi 6. So what's my ratio? So it's number of fingers to the right. 1 over 2. 1/2. Okay. 5 pi fourths. What's that one going to be? Good. Okay. 4 pi thirds. Square root of 3 over 2. All right. And then 3 pi halves. Remember, that's the point down here, which is 0, -1. So -1, yes. All right. It is. And then for that last chart, we got 5 pi thirds, 7 pi fourths, and 11 pi sixths. All of those are in which quadrant? 4. And in quadrant 4, sign is... All right, so these are also going to need to be negative. All right, so 5 pi thirds, that's equivalent to 60 degrees. So what's that?
3.
Right. So negative root 3 over 2. Okay? 7 pi fourths, what's that one going to be? So this is negative root 2 over 2. And 11 pi 6 will be negative 1/2. All right, and then lastly, we've got 2 pi, which actually is back at this point, right? This one I just circled right there. So it's 0.
Oh, okay.
Same as 0, right? Okay, so this is all the same stuff that we talked about in the last half of the unit, right? This was all on our last test. Okay, we said that these were going to repeat. They only change in different quadrants if their sign changes. Okay, so what they want us to do now is graph just the points of sine. So previously we were graphing sine and cosine to make our unit circle. Now I'm graphing only the points of sine. Okay, a couple things we need to consider is how much our lines are worth. So if you look down here, let's figure that out first before we start plotting points. It says that the third line here was equivalent to pi halves. And the sixth line is equivalent to pi. So how much did we go up to get from pi halves to pi? A half pi. So that means every single one of these that they numbered is going up in an increment of a half, right? Okay, but we can see that to get from 0 to this first line, they actually moved over 3 lines, right? Okay. So if I wanted to make this something that had a 3 in its numerator, 3 over what is the same as 1 over 2? 6. By a sixth, right? Because this is 3/6, and this would have been 2/6, 1/6, 0/6. So every line is a 6. Very good. Okay, so now that we know that each line is worth a sixth, feel free to label each line as 1/6, or just keep that in the back of your mind as we go plot them, okay? So that would make this line 1/6, the next line 2/6. But 2 over 6 is going to simplify to 1/3. So this would be pi thirds. Then we got pi halves. Okay, and then after that, I'd have 4 pi 6, and 4 pi 6 would simplify to 2 over 3. And then I'd have 5 pi 6, and then pi is 6 over 6, right? Then I would have 7 pi 6. Then I'd have 8 over 6, 4/3. And then you don't have to label it if you don't want to. 3 pi halves. And then after 3 pi halves, I would have 10 pi 6, 5/3. And then 11 pi 6, or 2, and then 2 pi. Okay? So again, you don't have to label it. I just wanted to point out to you guys that that's how much each line is increasing by. So that way we're not confused here in a second when we plot our points. Okay. All right, so now that we know how much each line is worth, let's go back to our table. Most of these, now I have an x value for, I just would need to identify my y value. So, right here, I can plot where 0 would fall. I can plot where 1/2 would fall. But do you guys know if square root of 2 over 2 is bigger or smaller than 0.5 off the top of your head? You may or may not know. Okay. So the way we would determine that is just put it in your calculator and tell me what it is as a decimal. So that way we can have an easier comparison for ourselves. So what is square root of 2 divided by 2, approximately? 0.7. Okay, so this is equivalent to 0.7. Okay, so that means it's a little bit bigger than a half, right? Okay, same thing with square root of 3 over 2. I may not know if that's bigger than 1 or smaller than 1. So I might need to put it in my calculator and see what it would approximately be. So what is square root of 3 over 2 going to simplify to as a decimal? 0.8 what? Okay, so it would round up to 0.9 if we just do 1. Okay, so 0.9. All right, and then we all know where 1 would be on a number line. Okay, so I'm going to go replace any of my square root of 2 over 2's in my chart, or not replace, but say that they are equivalent to 0.7. Make it easier on us when it comes time to graph it. And any of my square root of 3's over 2, I'm going to go mark that those are equivalent to 0.9. Okay, so if I look back up here, my first point was 0, 0, according to this chart. So I'm going to come down here on my graph, and I'm going to plot my first point at 0, 0. Okay, then I'm going to come back over here. What's the next point after 0, 0?
1, 2.
Pi 6 and 1/2. Okay, so that means go over pi 6 and up 1/2. Let's go ahead and make each one of these lines worth 1/2 so I can put it right on a line, because most of our numbers are going to be pretty small. So I'm going to say every other line is worth 1. So this is 1. Down here, this would be -1. Okay. After pi 6 and 1/2, what does our table say next? 0.7, and what was that for? What x value? Pi force. Okay, so pi force is not listed on our x-axis, but we know that 1/4 pi force is bigger or smaller than 1/3? Smaller, right? 1/4 is smaller than 1/3. So it's going to be to the left of pi thirds. Is 1/4 bigger or smaller than 1/6? Bigger. So it's between pi 6 and pi thirds. Okay, and you guys said that it's a point at 0.7, so that'd be right in here somewhere. All right, and then what's the next point on our table after pi force 0.7?
Pi 3.9.
Right, so I'm going to go over to pi thirds and up 0.9, so right below my line, that's 1. And then finally, the last value in that first chart tells us to plot a point at pi over 2, 1. Okay, so these are the points that made up the first chart that we filled in. Okay, let's keep going. So now I'm on the second chart. The first point on that second chart starts out with an x value of 2 pi thirds. So I go over to 2 pi thirds, and I'm going to go up how much? 0.9. Okay, so I'm going to plot a point up here at 0.9. Okay, then I have 3 pi force. Well, just a second ago, we discussed that pi force falls between 1/3 and 1/6, right? So it's going to end up being right in between these two lines, and it's at 0.7. Okay, next I have a point at 5 pi 6 and 1/2. So I go over to 5 pi 6, up 1/2. And then the last one in the second chart says I have a point at pi 0. Okay? All right. Then we've got our next chart. So now we're looking at the third one. Starts out with 7 pi 6, negative 1/2. So 7 pi 6 is this line. Negative 1/2 would be right here. Next, I've got 5 pi 4. So a fourth would fall in between my two lines, right? And it's at negative 0.7, so in the middle of these squares. Then 4 pi thirds is the next line, and it's at negative 0.9. So really close to that line, just not quite on it. And then finally, we got 3 halves which says the y value is at -1. All right, and then we just have one table left to plot. So 5 pi thirds says I'm at -0.9. 7 pi fourths says I'm at -0.7. 11 pi 6 says we're at -0.5. And 2 pi says we are at 0. Okay, so if I were to go back and connect these points, then my graph looks something like this, right? All right, so we talked about this back in the last unit, but we said that if I were to give you something bigger than 2 pi, like 3 pi, okay, well, on a coordinate plane, I would know, up here, I drew one, let's write on that one. Okay, so up here, I would know that this would be 2 pi, right, a full circle. So 3 pi would just mean to go a half more, and I land back somewhere I already have been, right? Let's say I asked you to go -4 pi. -4 pi would mean one full circle and then another full circle. So again, I'm still going to land somewhere I've already been, right? The points just repeat themselves over and over. So we only plotted from 0 to 2 pi on here, but I know that I'm just going to keep getting the same points if I were to go past 2 pi, right? Or if I were to go the negative direction, I would get something that I've already landed on, right? If I just go backwards on the unit circle, I'm not going to come up with any new numbers, is what we're saying.
Would it just like keep going up and then back down?
Exactly. That's exactly what would happen. So it would go from here, back up, and then come back down. If I was going the opposite direction, it's going to look something like this, right? It's just going to keep repeating that same pattern over and over again, okay? So it only took from this point to this point for us to get one full cycle in, and then after that, it just starts to repeat itself. Okay, so now that we've noticed that about sine, flip it over on the back, and we are now going to graph our cosine function. Okay? So, kind of the same idea. We already know if it's a quadrantal angle what those coordinates are. So this is the point 1, 0, where this is x and y, and r is always 1. Cosine is x over r, right? So what would cosine at 0 be? 1. Okay? And then I've got pi 6. Remember pi 6, that's this finger, and cosine is number of fingers to the left. So how many is that? 3. So this ratio would be square root of 3 over 2. Okay? Pi fourths. What's that ratio? Square root of 2 over 2. All right? And what's pi thirds?
-3 over 2, or 3 over, square root of 3 over 2.
So we're doing cosine.
Oh, yeah.
Cosine, cosine, yeah. Cosine, that would have been sine.
Yeah, that's kind of mixed up.
Okay? And then pi halves, I'm back up here. What would that be? 0, right. There's 0 fingers to the left. Or you can remember that this is the point.
Because square root of 1 is 1.
Okay? All right, and then after this, it's just repetition, right? I just fall in a different quadrant. Okay, so 2 pi thirds, 3 pi fourths, 5 pi 6. What quadrant is that? Second, okay. Is cosine going to be positive in quadrant 2?
No.
So all of these are going to be negative. Okay? All right, 2 pi thirds. The 3 in the bottom tells me it should be the same ratio as pi thirds over here, right? So what was that ratio? 1 over 2. So this is 1 over 2. It's just negative. All right, what about 3 pi fourths? What's that one? Square root of 2 over 2, because it's the same one as this, since it's got a 4 in the denominator. Okay. 5 pi 6, that should be the same as this one, so it's going to be Right. And then when I'm at pi over here, this is the coordinate point -1, 0. -1. Good. Okay. Next table, 7 pi 6, 5 pi 4, 4 pi thirds. Which quadrant is that? 3. And in quadrant 3, is cosine positive or negative? Negative, right. So these are all going to be negative values as well. Okay. 7 pi 6, got a 6 in the denominator, so that should be this ratio over here, which was, very good. Okay, our 4 in the denominator tells us it should be this ratio again, which was, good. And then 4 pi thirds, what's that one going to be? Right. And then 3 pi halves, that's this point down here, which is 0, -1. So 0. 0 over 1 is 0. Okay, then lastly, we've got 5 pi thirds, 7 pi fourths, 11 pi 6. All of that is in quadrant 4. And cosine is positive in quadrant 4, right? Okay, so pi thirds, what's my pi thirds ratio? A half. 7 pi fourths, what's our fourths ratio? Good. And 11 pi 6, our sixth ratio is nice. And then 2 pi, I'm back to where I started. So my ratio is 1, right? Because it's going to be x over r, so 1. Okay. All right. And again, what did we say square root of 3 over 2 was pretty equivalent to as a decimal? 0.9. So anywhere I see one of those, I'm going to be using 0.9. Okay, and what is square root of 2 over 2 equivalent to? 0.7. So all these I'm going to use 0.7 for. All right. It looks like our lines are still increasing by the same amount, right? So every single one of these lines is worth pi 6. So you can label them if you want, or just keep that in mind. Every line is worth a 6. And it looks like my numbers aren't going to range too much higher or lower either. So I'm, again, going to make every other line worth 1. So this is going to be 1, and this line down here will be -1. So we skip a line so that way we've got some room for our decimals. Okay. So I'm going to look at my table. My first point for cosine is at where? 0, 1. So on my table down here, I'm going to come plot a point at 0, 1. Okay? The next point is at 0.9, and what x value? Pi 6. And remember, pi 6 is one line, right? So I'm going to go one line to the right, and I'm going to go up to 0.9. So right below the line 1. Okay? Then we would have pi fourths. Remember we said a fourth is between 1/6 and 1/3, so this is the one that's in between the two lines. And they said it's at positive 0.7, which would be kind of in the middle of this square. Okay, then I've got pi thirds, which would be my next line. And what's the x value at pi thirds? 0.5, okay? And then at pi halves, what are we at? Okay. All right, now we just need to keep plotting our points. So now I've got 2 pi thirds, so that's the next line. But my my y value now is at -0.5, so I'm down here. Okay. Then 3 pi fourths, fourths, remember, is in between the lines, and I'm at -0.7. And then for 5 pi 6, I'm at -0.9. And then by the time we get to pi, my y value is -1. Okay? Then we're at 7 pi 6. So next line, I'm at -0.9. And then we've got 5 pi fourths. So again, in the middle of two lines. And it's at -0.7. And then at 4 pi thirds, I'm at negative a half. And by the time I get back to 3 halves, I'm back at
1.
0.
Oh, actually, I have it drawn down there if you would actually take a peek.
Okay, last chart. So here for 5 pi thirds, the next line over, I'm at positive a half. And then for 7 pi fourths, which is in between, I'm at 0.7. And then for 11 pi 6, we're at, and then for 2 pi, we're back at, there we go. Okay, so if I were to go and connect these points, this is what it's going to look like. Okay, but the same thing is true. If I asked you about 2 pi or negative 7 pi or 14 over pi thirds, right? It's going to keep falling on the same points as I go around the circle, right? I'm going to see the same thing over and over again. So just like before, it might have taken me this long to get one cycle through, but now that I've made it this far, it's just going to start repeating itself. So it's going to come back down over here. And over here, same thing, going to come back down over here and then back up and so on and so forth, right? We're just going to see the same thing happening over and over again. So what do you guys think about these two graphs? If I were to ask you to make a comparison between the two, what do you notice?
They're opposites.
In what way?
Like the sine one goes up first.
Okay.
And the cosine goes down first.
Okay, so he's saying that this one started up here at 1 and it goes down first, while this graph over here started at 0 and it went up first. But after that initial starting point, do they make the same shape? Yeah, they're going to make that same curve over and over and over again. Okay.